nobody really expected this. The James Webb Space Telescope has discovered 15 strange galaxies that existed before the Big Bang. With this discovery, we are now at the beginning of a completely new era. Our cosmology and science as a whole will experience an unprecedented upheaval, and our entire view of creation and its causes may change completely. What if the Big Bang never happened? Are we possibly looking into a parallel universe? And why has our science failed? Nobel laureate Dr. John C. Ma, the lead project scientist for the Webb Telescope, put it in a nutshell at a press conference on current events. "We thought we'd see that far, but we didn't think we would see what we're seeing. Yeah, we thought the galaxies would be smaller, cooler, darker, and now we are surprised. We just don't know why they're that way. Are there any great ideas bubbling up? We don't know yet what's different between our plan for the universe and the actual universe." Big surprise! We are feeling that the early galaxies grew much quicker than we thought they would. They're bigger, brighter, hotter, more massive than people expected. James Webb's images show a number of objects so strange and so old that they are puzzling scientists. Most are too complexly organized and structured to have been baby galaxies 300 or 400 million years after the Big Bang. Scientists expected some clusters to harbor the legendary population 3 stars. These first stars are said to have been huge and luminous, but had short lives. The shocks continued, and James Webb discovered another galaxy. It turned out to be so dim that it does not fit the picture of clusters of bright supergiants. Another discovery could be 6 black holes that were already so massive 500 million years after the Big Bang that we have to wonder where all the matter came from that made them grow to this size. Current cosmological models tell us that it takes billions of years for galaxies or black holes to take on the shapes that James Webb is now showing us at the beginning of time. James Webb has a range of about 13.5 billion years. The telescope is not much better than its predecessor, Hubble, but Webb looks more clearly into space and sees more detail. The oldest galaxy discovered by Hubble was GNZ 11, which existed around 13.4 billion years ago. James Webb has now discovered dozens of galaxies in the depths of the cosmos, some with incredible redshifts of up to Z equals 20. 15 of these galaxies have now been confirmed, and scientists must now explain their existence. These galaxies become visible to us because of the light they once emitted. Telescopes capture the light and act as real-time machines. We look into the past as if through a tube, and can get a vivid impression of what the universe looked like at the beginning of time through light signals that are billions of years old. In addition to light, there is another major indicator in the universe: the cosmic background radiation. The cosmic background radiation, or cosmic microwave background radiation, is a remnant from the early days of the universe. As an almost uniform radiation field that permeates the entire universe, it still carries messages from distant events through space. It was discovered rather by chance in 1965 by the American physicists Arno Penzias and Robert Wilson when they noticed a strange noise in space. It is perceived by gigantic radio telescopes as a weak microwave signal coming from all directions in the sky. Their discovery confirmed, among other things, the Big Bang theory and the assumption that the universe is expanding. The background radiation is a reflection of the state that existed around 380,000 years after the Big Bang, when the universe very slowly began to release photons and produce light. So, even with the background radiation, we cannot see all the way back to the Big Bang. However, cosmic background radiation helps us to reconstruct the composition, density, and temperature of the early universe. Scientists can read thousands of details from cosmic structures and details from tiny fluctuations in their uniform distribution. These observations have so far helped to explain common cosmological models, but now we have to question these findings too. At the same time, while researchers are now on the trail of the latest mysteries of light, such as luminous galaxies or brightly glowing disks of dust from black holes, radio astronomers are still listening into space, trying to use the cosmic background radiation to listen even further back in time and find clues to what really happened back then. What many people do not know is that it is not only since the new James Webb era that unusually old galaxies have been discovered. Back in 2016, a team of researchers led by Pascal Oesch and Gabriel Illingworth used the Hubble Space Telescope to identify a very old galaxy at a redshift of Z equals 11.09. The light from GNZ 11 had traveled for more than 13 billion years before it reached Hubble's field of view. This redshift makes GN-Z 11 the most distant known galaxy. GNZ 11 caught the attention of scientists not only because of its enormous distance, but also because of its unusual physical properties. Despite its young age by cosmic standards, GNZ 11 is surprisingly bright and large. At the time we see the galaxy, only 400 million years had passed since the Big Bang. This means that GNZ 11 must be one of the oldest galaxies from our point of view, but at the time it was young and surprisingly well developed. Scientists estimate that it took billions of years to form complex galaxies like this one, with an estimated mass of about 1 billion solar masses and a star formation rate of about 20 solar masses per year. It also shows unexpectedly rapid evolution and activity. Observing and analyzing GNZ 11 in 2016 was a technological challenge. Not only is the light from this galaxy extremely faint, but it is also so heavily redshifted that it pushed the capabilities of the Hubble Space Telescope to its limits. Of course, researchers were already puzzled by this strange find in 2016, but back then, GNZ 11 was just one galaxy among many, and was considered an exotic one. Now we know that there were probably thousands of highly organized and massive galaxies in the early universe. The James Webb Space Telescope is really blowing researchers away at the moment. One discovery after another is making the scientific community look old. All those who thought they knew what those first galaxies and stars looked like are now being shown something else by the universe. JADE's GSZ 13111 is a high redshift Lyman break galaxy discovered by the James Webb Space Telescope on 29 September 2022. This discovery was made as part of the JWST Advanced Deep Extragalactic Survey, or JADES for short. As its name suggests, JADE's GSC 13111 has a redshift of 13, which means that the galaxy existed around 13.4 billion years ago, just 400 million years after the Big Bang. Only James Webb has been able to capture the light from this extremely distant galaxy using a technique specially designed for infrared observations. Redshift is a phenomenon in astronomy that is closely related to the expansion of the universe. It occurs when the light from stars or galaxies is shifted towards longer red wavelengths. The reason for this is most likely the expansion of the universe, but it can also be caused by the movement of objects in a gravitational field or by the Doppler effect, where the movement of the light source is relative to the observer. The effect was first observed in the early 20th century by astronomers such as Vesto Melvin Slipher and later Edwin Hubble. Hubble found that distant galaxies exhibit a redshift proportional to their distance from Earth. This observation gave us the Hubble law, which not only describes the age and direction of motion of galaxies, but is also the basis for the theory of the expansion of the universe. Just when researchers thought things couldn't get any worse, another one appeared. Sears 2112 added to the confusion. This barred spiral galaxy is not quite as old as GNZ 11 or JADE's GSZ 13111, but at Z equals 3 it is an almost exact twin to our Milky Way. Spiral galaxies normally take many billions of years to form, but Sears 2112 can only be 2 billion years old when it emitted this light. The high redshift shows that Sears 2112 is from a time when the universe was somewhat older but still in its infancy. The stellar mass of C2112 is estimated to be about 3.9 times 10 to the power of 9 solar masses. This also suggests that the galaxy was already in a relatively mature state when the universe was only 2 billion years old. This raises uncomfortable questions about how a galaxy could develop such mass and structure so soon after the Big Bang, given that galaxies take billions of years to evolve. We are certainly not looking at galaxies that are only a few 100 million years or 2 billion years old. These galaxies must be older, which means that they must have existed before the Big Bang. You probably already have a theory or two about how to explain the great age of these supposedly young galaxies. Let's have a look at the possible solutions. In the wake of the James Webb Telescope's shocking findings, we have to consider that the universe is much older. There is even a theory developed by Canadian-Indian researcher Rajendra Gupta. He explains the theory of the expanding universe by light tiring as it travels through space. If this assumption is correct, then all our previous distance measurements could be wrong. So far, there is no real evidence for the Big Bang, only the expansion and the cosmic background radiation. But these observations may be wrong. In quantum mechanics, we find several indications that the universe is infinite in time and space. There was another beginning. In addition to the idea that the universe expanded from a single point, scientists suspect that there are at least a dozen other explanations for how our cosmos came into being. One of these is that the universe is fed by multiple sources, and that these sources did not all come into being at the same time.